Sorry, I don't want to give away my shirt too quickly. It's T-shirt Tuesday, remember. Good afternoon. How's everybody doing? That good, huh? Everybody's doing great. Silent as can be. I know it looks weird. You can only see my head, but I didn't want to give away my shirt yet. It's T-shirt Tuesday. T-shirt Tuesday. Did you forget? It's okay if you forgot. If you have a T-shirt in your closet that you don't want to put on, but you could hold it up, you could totally do that. I'm doing okay. I'm hanging in there. I'm feeling a little grading pressure that I better get grading tonight. It's okay. I'm going to be grading. Okay, Kelsey. No worries. Yeah, I'm going to be a grading fool tonight. I graded some stuff, but there's just a lot. And you're like, stop assigning things. Yeah. But if I stop assigning things, then you don't do things. So I could just say, this is an optional assignment, but guess what happens when I say an assignment is optional? No one does it. Right? And those video assignments are not too bad, right? They're pretty quick. Not too bad. What I notice is I just have so much stuff because this is such an amazing class that I'm never going to get through the slides that I plan. So it's okay. I have an alternate plan for you today. Well, I mean, for every day now, but I'll explain it shortly. It's so nice that I recognize faces now, so I don't have to be like, who is this person? Who is this person when I'm taking attendance? Which, if you thought taking attendance in person was bad, you ain't never took attendance online. Attendance is my downfall, I will have to say. Like when I was a classroom teacher, it was terrible. I never had a good plan for attendance. And I taught middle school, right? So you have to take attendance every class period, right? That was awful. Awful. I just let someone in and I can't remember who it was. See, I can't even do it right now. But the pressure you guys have when you take attendance when we're all back face to face is sometimes you guys have to put in lunch orders. Yeah. Yeah. I could barely do attendance, let alone put in lunch orders for crying out loud. I feel like that is not part of my teaching assignment. I feel like someone else needs to be in charge of that. And there's some classroom teachers that are amazing at that. Yeah. Like, I don't know how they're so good. So, but my kid's 5th grade teacher, she had it down to a science because she had technology in her classroom. She was one of those teachers of the future or whatever. So she got like a whole iPad cart in her room that was like her iPad cart, not the school's. And so each kid had their number, and that was their iPad number too. And so they would just count in the morning. And I don't know, she had some weird system. I'd have to have my kids write it down and explain it to me because I can't even follow it as an adult. And so she could take attendance like this. It was amazing. Not me. Can't do it.
I have a question.
I'm ready.
For the big pig, the big plus pig equals barn.
Yes.
So the problem is just the big and the pig representing two digit numbers and the barn 4.
Yes. So it's 2 3-digit numbers sum together, give you a 4-digit number. Does that make sense?
Oh,
And then I tell you which digits are available, right?
okay. So the digits that you posted below are the ones that we can use, that are available, that we can use.
Yeah.
But we just have to do it in the in the what is it called? I had a brain freeze.
I don't know, but it's kind of like a puzzle. So the I in both of the parts of the addition sentence represent the same number.
Oh, okay, okay,
Yes. So like if the I is a 4, it's a 4 in the other number.
okay.
Yeah.
It makes sense.
Yeah.
Okay.
It's a fun game. Let me know how it goes. And the more you practice on step 1, the better step 3 becomes. Like if your whole strategy is guess and check, you might be crying. You might want to go back and rethink that guess and check strategy. Go back to your givens and your goals because you'll get better.
Okay. Thank you.
Thank you, Hannah. I was very confused at who Rebecca is, but I got it. That's Hannah Miles. I got it now. We're good. Okay. Okay. So I sent you a little message this morning that said if you have access to the slides, it's going to help you, right? So if you pull up my slides in another window, you don't have to do it right this second, but just so everybody should know where they are, right? It's just a PDF that I post on Canvas. That's the word. Okay. Yeah. And if you can't, it's okay. Someone in your group will be able to. T-shirt Tuesday. Anyone have a shirt they want to share? No. Karina, what's on your shirt? I see words. Oh, okay. What does it say? I can't read it. I don't know why. I need to make you bigger on my screen.
Yeah, it says we need each other for our own inspiration.
Okay, and what's that character from?
Kiki from Kiki's Delivery Service.
Okay, I knew because I've seen that before. So there you go. I don't know the names of any shows. You will find that very annoying about me, or the names of any actors. So I describe a show and it's so vague you can't even figure out what it is. Yeah, super fun game that we like to play. Okay, anyone else have a t-shirt? I just made Karina share hers. Okay, then I guess you're ready for mine, right? You're ready. It's true. Okay, if you get the reference, please respond in some way. I can't see the bottom. Sorry. It says, I got skills. They're multiplying. Thank you, Bethel. I appreciate you. Okay. Oh, I got some more. Karina, Elena, Tyler. Oh, McKenna, what's it from? Evelyn. Greece. Yeah. Oh, thank you, Jessica. Right there. And I'm losing control. Yes. Okay. So you too can be a teaching nerd and wear these shirts for your students. We are going to start multiplying tomorrow, but it's T-shirt Tuesday today. So I picked the shirt because we are multiplying. It's awesome. So students love these awful shirts. I'm telling you. So that's a multiplication table right there, just in case you're wondering. Oh, I find them everywhere. People started giving them to me now. So Amazon is an easy place to find them, but Walmart, believe it or not, has some moronic shirts for math. But yeah, you can find them anywhere. They're all over the place. Woot is one of my favorite shirt places. So WOOT. Okay. So yeah, I got skills. They're multiplying. Kids are like, can you wear that on test day? Because I can't remember my multiplication tables. Don't do that. Don't wear this on test day. Because then you'll find kids be doing like this all the time, trying to find you. And they call you over to ask you a question. Yeah, it's funny. Okay, so there you go. Yeah, if you don't know the Grease reference, I'm really sad and you should all go watch Grease. I'm just saying that's a separate side note that has nothing to do with math education. Okay. It is electrifying. We could do this all day. Yeah, it's true. And I usually do it all day, but the kids have no reference of Grease. So then I tell them to go watch Grease. And then if they're in second grade, their parents are like, why did you just tell my kid to watch Grease? Yeah, it's a little traumatizing. It's okay. Okay. But they get it. I mean, they've heard of it, right? They've done oldies dances. So, Okay. Hopefully I'll get to the right place. I modified our slides from yesterday just a little bit. And these should be up here. Oh my gosh. Sorry, my finger's not working. I know, it's troubling. So I know we're not going to get through all the addition slides, but what I did on some of them is I put an example of the solution on the next slide. So you could just reference that on your own if you need to finish those slides. I think you'll be fine without it, but just in case you need it. First thing I want to talk about is yesterday we were doing adding and subtracting story problems. Yeah. Did you start your homework? It wasn't too bad. The worksheet. I mean, it was kind of long. I know, but it was very similar to what we were doing in class. Oh, your exit ticket. I want to give a shout out to Elena, Michaela, and Tyler. They got 2 out of 2 on the exit ticket. The exit ticket yesterday, a lot of you thought the problem was a join problem, but it was not a join problem. I was going to read it to you if I lost it. Okay, I did lose it. It was Kylie wanted to buy a pair of jeans, something, or a shirt. How much more money will she need? Do you remember that? Does that sound familiar? As soon as it says how much more money will she need, it's comparison, right? So it's not join because it didn't say she bought a pair of jeans. That would be the action. Okay. So she just wanted to buy. So how much more? So it would be compare. I think that's where most of you went wrong. Most of you picked the right equation, which is good, the important part. Did you know that parts of an addition sentence have names? Yeah, so there's 2 numbers that we're adding together. Most of us knew that the answer at the end of the subtraction problem was called the sum. How many of us knew that? The answer to an addition problem is called the sum. So if it says sum 2 numbers, you're going to add them. We know that. But did you know the 2 beginning parts are called addends? ADDENDS. Yeah, you should know that vocabulary and you should use it. And kids know it too. Now, teachers teach it to them. Did anyone learn that in school? Yeah, me neither. But kids know it now. Crazy. And they're named the same thing. And we're going to talk about why they have the same name, addend, sum, when we get through to subtraction more. And we might say things like the sum of 5 and 8, or 8 added to 5, or 8 more than 5, or 5 plus 8. Now, I want you to think for just a minute. It says discuss with your team, but that's a lie. You're going to discuss it with your mind, and then you're going to discuss it with me. How do you add 7 plus 8? Like, what's your strategy, or what is a kid's strategy? And you can think of 6 plus 9. Think of your strategy of what you do. You might even want to write it down. So think about what you do to get those answers. I'll give you about 1 minute. And you can't just say, I just know it. That's not an option. That's not a strategy. All right. So anyone tell me a strategy that they used for 7 plus 8? Or they think a kid would use for 7 plus 8.
I could go.
Okay.
So one thing that I think a kid would use, and I actually seen this mainly in kinder first grade, is I don't know if y'all can see it, but they would draw like bubbles or like little blocks to represent like the one. So like we have eight bubbles on top, and then 7 bubbles in the bottom, and then you just count them all together, and that equals to 15. And I didn't get time to do 6 plus 9, but it would be the same thing.
That's okay. Good. Who else has a strategy that they might use or used?
I got one.
Okay.
So in my elementary, I don't know if it's used anymore. I had a teacher saying, do what you know first. So like for 7 plus 8, I know 8 plus 8 is 16. So I took one away for it to be 7 plus 8. So now I know it's 15 because 16 minus 1 is 15. And then I kind of did the same thing with 6 plus 9. I know 9 plus 9 is 18. So take 3 away for it to be 6. And then 15. And
Nice. So with that first one where you said 8 plus 8 is 16 minus 1, right? That's called doubles minus 1. That's a strategy because doubles is a strategy. Yeah, students know doubling. So good job, Jessica. Yes, it's still used. Excellent. Any other strategies?
Very similar to Bethel's. Instead, I use tally marks, and they're actually really small, so I apologize if you can't see them. But something that kind of went through my brain is you just take the tallies of each one, so you can count out 1, 2, 3 through 7. I kind of shorthanded it because I'm a little impatient, and then you count them all together, and that equates to the 15.
Nice.
For me, like I thought about using like finger math, and I know like there's an 8. I know that there's a 2 in the 7, and then it also has a 5, so that'd be 15. And I also kind of wrote out the thinking. Like here's 8. I broke down the 7 to a 5 and a 2, so 8 plus 2 is 10, and then 10 plus 5 equals 15. And then I did the same thing here.
Nice. You're right up there with what we're going to do today. That's really nice. And that's a strategy maybe that's called make a 10 strategy, because that's when you broke down that 7 into 2 plus 5, you did 8 plus 2 to make a 10. So make a 10 is a good strategy. Anyone else?
So for me, I think someone kind of said something a little bit similar, but I did the compensation method. Is that what it's called?
Yep.
So, okay. So with the 6 plus 9, I added 1 to 9, making it 10. And then I knew 10 plus 6 is 16, and then subtracted 1. So I got 15.
Excellent. That's a great strategy. Very nice. So-
I did
oh, go ahead.
doubling as well, but I did 7 plus 7 is 14, and then I just added 1. And then I also did 6 plus 6 is 12, and then I added 3 instead of subtracting instead.
Excellent. So there's lots of different ways that we can do these, right? We don't all do them the same way. And some of you are like, I haven't even thought about how I do it in a long time, right? But that's okay. That's what you want to start thinking about. These are some strategies that our students would use. So I'm going to share a different screen for a minute because you guys brought up some really interesting strategies, if this will load. So how many of you watched the video on the overview this week of number talks? Did anyone watch that video of number talks? I think that's what it was this week. Anyone know what number talk? Oh, good. Hannah watched it. So anyone know what number talks are? So number talks are when you practice mental math in a classroom. There's actually a book called Number Talks, and it's pretty popular. And so I don't know if you remember math when you were in elementary school, but for most of you, you just sat at your desks and the teacher talked to you, and the teacher did the math, and then the teacher had all of you do the math together, and then you did the math on your own. That was a teaching strategy, and it's called I do, we do, you do. Yeah? Have you ever heard of that? That's do. Don't do that. Okay. That's a terrible strategy, even though most of you learned that strategy. If you're in a classroom where a teacher goes, I do, we do, you do not tell them it's a terrible strategy. Do not say my teacher told me to tell you that that's a terrible strategy and you shouldn't do that, because they've probably been teaching a really, really long time and maybe it works for them, but it's creating non-thinkers is what it's doing. It's creating just people who can mimic what's happening, right? And that's not what we want to create. We need to create problem solvers. So number talks is you bring kids down to the carpet, even in like 5th and 6th grade. They sit down away from their desks, no pencil or paper, and they do mental math problems. And some of them are hard. Yeah. And what they do is they think about their strategy. When they come up with one strategy and an answer, they put their thumb up, and they do it usually discreetly, right? So they're not distracting the rest of the kids in the class, but the teacher can see everyone's. And then the object is, as a teacher, you wait till everyone has at least a thumb up. If they're still thinking, they will put their thumb sideways, right? If they have a strategy, they'll put their thumb up. Their job is to come up with as many strategies as possible. Yeah. And then they talk about those strategies all together. It's fascinating. Kids are amazing strategists. And the teacher then records up on the whiteboard the students thinking. Okay, so they can see the differences. So here's an example of some of the students thinking, or what a student might be doing incorrectly, or how they told you to write it. So we have Scott, Martin, and Melissa, and their job was to add 9 plus 8 plus 4 plus 2. And you can see how Scott described his strategy, and the teacher records exactly what the student tells them to, right? So that's what happened with Scott. And then Martin's strategy in the middle, and then Melissa's strategy. So take a minute and just look at these and see if you can find anything good, bad, wrong, right, anything about that. I'll give you about 30 seconds to look at these. All right. So any comments about any of them? I'm just opening it up to you guys.
With Scott's, I mean, for me mentally, like that was super easy to follow because it wasn't necessarily like there wasn't an order of operations you had to do. He just took each one went side by side. But as I'm looking at like Martin and Melissa's, I don't know if it's just me, if it's because I really feel like I'm dyslexic or what it is. I can't for the life of me figure out what's going on in those two boxes. I just know that I see the answer and then I see all of the work, but none of the work seems to make sense.
I'm so happy you said that, Tyler. First of all, remember, this is not a kid's work, right? This is a kid was talking, explaining it to the teacher, and the teacher was recording. So we'll go through it in just a minute. But first, I do want to talk about Scott's, because many of you said Scott's was easy to follow. Yes. And I will tell you, Scott's, the way he described it is mathematically wrong. His answer is correct. But his problem is when he said these things. If you put a hard equal sign there, it better be a fact. It better be true, right? And if I follow this, that means 9 plus 8 equals 23. Is that true? That is not true. Now, that's not what he meant, right? But that is what he described to the teacher. He said, 9 plus 8 equals 17, plus 4 equals 21. And she asked as he was doing it, right? Should I write an equal sign here? And he said, yes. So what he really should have written was 9 plus 8 equals 17. Then 17 plus 4 equals 21. Then 21 plus 2 equals 23. Yes, he went left to right, but having these hard equal signs means that all of these things are equivalent. So do you see how his thinking might have some trouble, even though he got the right answer? Okay, so you're like, oh gosh, the one I understood is the one she just said was wrong. No, it's okay. It's just the notation that was wrong, right? So he would just have to revise the way he worded things to his teacher. Martin's. So what did Martin do right here from, let's look at this first original one to this next line. What did Martin do first?
He like rearranged his numbers around.
Yeah, he changed the order of this. Is there a property that's mathematical that allows you to change order of add-ins? Anyone know what it might be called? Do you agree that 4 plus 8 and 8 plus 4 are the same thing? Yeah, it's called the commutative property of addition. Does that sound familiar? Commutative property of addition means I can change the order of the add-ins and I haven't changed the problem, the value. Okay. So, by the way, the properties are on your midterm. I'm going to give you a foldable of them next week. Okay. They're in the slides later, but just so you know. And commute, I don't know if you know that word, commute, but like that's your drive to and from work or to and from, you know, wherever. And the commute, the distance you drive is the same. Now, the time might not be the same, right? But the distance is the same. So it doesn't matter if you started at home and you went to work or you started at work and went home, you still drove the same amount of distance. So that might be a nice way for you to remember commute. Okay, then what they do here, they broke down the 4. They said, okay, 4 is 1 plus 3, right? And then they said 8 plus 2 is 10. Then they said, oh, 9 plus 1 is 10. So I'm going to erase this so you guys can see these arrows. Do you see they broke down 4? This arrow should really be right here. The 4 into 1 plus 3, that's called decomposing. Right here, they put together 8 plus 2. So they recomposed the 8 plus 2. So the strategy is decompose, recompose, right? And it uses the commutative property. Okay. And then again, they composed, and they got their answer of 23. So what the students described is what was happening here, right? And believe me, students are doing this. Now let's try to figure out what is happening to Melissa's. Maybe now that I described that splitting notation, it'll be easier. So they decomposed or split 9 into 8 plus 1. Then what happened right here? What property?
Is it the commutative property of addition again?
It is the commutative property of addition. Good job practicing your vocab, Madison. That's perfect. And then they used a doubles strategy here, right? And then they just used friendly numbers here, right? And they got to their answer. You're like, oh my gosh, math has changed so much. What is happening right now, right? We don't want to just teach kids one strategy to use it. We want them. How many of you are good at mental math? Anyone? A couple of you, maybe 3 of you. Anyone bad at mental math and willing to admit it? My hand's in the air, by the way. I had to practice and practice and practice these things, right? Because I was never taught it. I was never taught to think. I was just taught to use a procedure. So now I'm getting better and better and better at it the more I practice. So there is hope for you, just so you know. Okay. All right. So I thought that was very fun. Now, here's some splitting notation. You can see they did 47 plus 19. And here's 2 different strategies. Now, this is obviously much older kids, right? They're not doing single digits. Now they're doing multi-digit addition. So 47 plus 19, this was decomposing by place value. So notice that they broke down the tens and then they broke down the ones and they summed the tens and they summed the ones and then they added them. This is actually a great strategy. How many of you, if you were given this problem, would do this? 9 plus 7, and some of you had to go. It's okay. I know you. It's all right. I'm not judging. I'm just being facts, right? So here we go, right? And that's how you do the problem. It kind of took you a long time. Kids in elementary school who know this strategy get the answer really quickly. It's amazing because they're thinking differently and they're practicing it. The other way is you can make friendly numbers. So they said, oh, it would be really nice if this was a 20 instead of a 19 because 20 is hard. So they said, oh, I'll just take one from here and give it to this one. So 46 plus 20, that's a lot easier of a problem. 46 plus 20 is a lot easier than this, right? Because we don't have to do that regrouping. So I'm going to put a Jamboard in the chat for you. I don't even know if I can get you in your teams. We'll see how slow I am today. That's a lot of my time comes to that. And I want you to try this strategy with another problem.
I'll call
Okay.
her.
Try this strategy with another problem. Actually, you can just pull up the Jamboard. You can find your team page, I'm sure. Make sure you're on your team page. I'm pulling it up right now so I can see it. The first slide is just directions. The second slide is the problem. So, and it says team 1. There's a Post-it note, a blue Post-it note in the right corner. Hopefully you remember which team you're on. So you should be able to write on this now and do whatever you want. So you're going to do the problem 29 plus 58. So you can start on it even if you're not in your breakout rooms, because I know you're not. Okay. So do you have editing privileges or are you having trouble writing on this? I think you do. Yeah, you do. I can see team 2 working. And it's okay if you're writing a different strategy than someone else. It's totally fine. And you can privately chat with your team since I have you in here. Sometimes when I move you guys back and forth, it just takes so long. And I lose some people that get kicked out of the room.
4, 5, 6, 7.
Okay, if you're not writing on the Jamboard, at least you're writing it on paper and thinking about it. Yes? I love how some of you are like, it's terrible to write on this Jamboard, right? You can type on it too. You know that, right? You can type. You just pick a text box and type. And then you only have to draw in the arrows, right? Just so you know. And then you'll notice on the next slide, it says compensation. And we haven't talked about compensation yet, but some of you might have been reading your homework or working ahead doing the addition strategies. Okay, so before I put you in breakout rooms and you're just thinking about those things, I'm going to share a video with you. Okay. And so just be thinking while I'm playing this video and watch how this kid solves the given problem that they're given. Okay. If I can figure out where the video is that I'm sharing.
Seeds on the ground. A bird ate 7 of the seeds. How many seeds are on the ground now?
Okay, can you see a little boy with snap cubes? Okay, I'm going to start it again.
There were 15 seeds on the ground. A bird ate 7 of the seeds. How many seeds are on the ground now?
$17.
15.
Oh. It just sounds like the same. Maybe 7. $8.
Okay, I see what you did on that.
There was one strategy, okay? I'm going to show you another video. I love to see these kids doing math. So watch this one.
So this is a story about Camilla, and Camilla's saving money to buy a book. Camilla has $7. She wants to buy a book that costs $11. How many more dollars does she need to save so she can buy the book?
I grab 7, 1, 2, 3, 4, 5, 6, 7. And I have to count. And I have to count to 11. 8, 9, 10, 11. $4.
So she needs to buy have $4 more to buy the book? Okay.
Okay, so on the first problem, we'll talk about what type of problem that was and then how we solved it. And then the second problem, you saw how she solved it. Now watch this one and watch this one very carefully.
Had 8 animal crackers. His sister ate some of them. Now Sam has 6 animal crackers. How many animal crackers did Sam's sister eat?
Can you read that again?
Sure. Sam had 8 animal crackers. His sister ate some of them. Now Sam has 6 animal crackers. How many animal crackers did Sam's sister eat? Yeah, I can read it as many times as you want, okay? Sam had 8 animal crackers. His sister ate some of them. Now Sam has 6 animal crackers. How many animal crackers did Sam's sister eat? So what did you get?
She ate 2 more.
Uh-huh. And how did you figure that out?
Because there's 8 and then 7 and then goes 6.
Oh. And so where are the animal crackers that Sam had at the end?
These ones his sister ate.
And where are the ones he started out with?
All of these.
Oh, nice. And then I noticed you wrote a number sentence. Could you read what you wrote?
8 minus 2 equals 6.
Uh-huh. And then you boxed the 2. Why did you box the 2?
Because his sister ate 2.
Mm-hmm. That was the part you figured out.
Mm-hmm.
Nice thinking.
All right, but I don't know about you, but that is the most fun thing to watch ever is kids doing math. Now, that's why I should never teach that grade because that would have killed me just to make the video, right? Because I would have sat there like, oh my gosh, can you work a little faster? Yeah. So my patience is not that level. So those of you that are that level, I mean, they are adorable and I could do it for an afternoon, but I could not do it as a career. Did you notice anything that would connect yesterday to today in those videos? Yeah, boxing the unknown. Did you notice the different structures that they were given? Yeah, and they were given different types of problems. The very first one, there were 15 seeds on the ground. A bird came and ate, what was it, 8? How many seeds were left? So that was a separate problem, right? And it was result unknown. The middle one that we watched, the little girl, where it was somebody wanted to buy something. She has $7. She needs $11. How many more dollars does she need? So that was a compare problem, right? And it was the change unknown there. And then that last one, again, it was a change unknown. And it was fascinating to me that she did the structure exactly like we wanted her to. Now, she did write her 2 backwards, which has nothing to do with math. So thank goodness, right? But how cute was she? And did you like how she kept having to ask them to read the question again? But she was processing that. What else did you notice about those videos? What did they have available to the kids?
They had available the little blocks.
Yeah.
So visual.
Yeah, they had a hands-on manipulative. They also had paper. And just like Bethel, you described at the beginning, they could just draw them, right? So absolutely. Okay. If I looked back at your Jamboard, I know some of you are like, I didn't look at work at the Jamboard. I was watching the cute little adorable children. That's totally fine. And this Jamboard is now, you can work on it whenever you want. So, and you can review it. And as some students know, I put sticky notes on your boards after class or later in the night. So you can always review your boards and see what I put on there. But I'm going to share, I think a lot of you did pretty well on getting that first part done where you decomposed by place value and then you decomposed by making friendly numbers. And a lot of you did it the same way. I'm guessing a lot of you did it. Am I sharing my screen? I have no idea. Yeah, I didn't think so. Actually, I had no idea. That's just facts. Okay. So maybe some of you did 29 plus 58 like this. You didn't have to. I'll look at yours later. So decompose by place value, 20 plus 9 plus 50 plus 8. And you add the 20 and the 50 together and the 9 plus 8 together. And then you have, oh, and my answer is wrong. That's supposed to be an 8. That's obviously me moving things around. 87. Very nice. And then this one, you can choose. So I just did a couple examples. You could just split up the 58 into 57 and 1 and make it 29 plus 1 is 30. Or you could split up the 29 into 27 plus 2 and make it 27 plus 60. It doesn't matter, but that gives you an idea of how you did it, right? Yeah, and no one used the tens that were already made. I noticed that too in those videos. Nobody used that. That was fascinating. Okay. I have some examples here. I don't know if you noticed at the beginning of class, I have some books on my bookshelf in my virtual classroom. Oh, I must have moved it. So, but I have a book in my virtual classroom and these are pages from the book and it has a lot of nice examples. If you click on my virtual classroom, you can click on that. And it'll take you to the Amazon link. The reason I like the book a lot, it's called Math is Power, I believe. The reason I like it is because it's in English and Spanish. So it's fascinating to have both of those resources. The other thing is you have an assignment where you have to do things with base 10 blocks. Yes, this week. And it's a manipulative. Here's an example of how you do it. So 146 plus 88, you model both add-ins. Then you have to make some trades, right? So you can add and then you count the remaining blocks. So when you do your home addition blocks activity, you have to have screenshots of each step and you have to have words by each step. And some of you are like, oh my gosh, that is a lot of technology going on there. Yeah. The easiest way to do it is to do it in a Google Doc, right? Where you can put the image and then you can make a text box right next to it, or you can surround the image with text. So I shouldn't get 50 screenshots separately in a document. That should not be a thing. And I shouldn't get all your screenshots and then all your steps, right? I should see it as one piece. If you're struggling technology wise, just come visit me and we'll do it. You can work with your teammates too to make sure you figure it out. But here's an example of how you do it. I have more examples down here. This is how you would do it by hand. Model both add-ins, join them together since it's addition, make a trade, and then count the remaining blocks. So what I did here, I don't know why that just disappeared. What I did here was I included some examples for you of all the different ways to solve addition problems, okay? These mental math problems, try these real quick. Just think about how you would do these. All right. So just quickly, how would you do any of these problems? Tell me what you would do to make them easier mentally.
I would do the compensation method.
Okay. Explain.
So just looking at the last one, like the 324, I would add the 6 to that and then make it 330 and then add 37. And I feel like that's a little bit easier to see mentally. And then same with the other two. You could add the 2 right before it to the 198 and make that 200. And then the one before that, you could add the 1 to the 5,999.
Very nice. Now, is that compensation?
Is it like the modified add-ins or compensation?
Compensation is a little bit different. This is just using the commutative property, right? That's all we're using here to change the order. But compensation, I'm so happy you brought that up because I have that in here. Oh, and here's exactly what you just discussed, right? So on that next page, I swear I have compensation.
It was on like the ways to show addition.
Yeah, and it's a great strategy. So what compensation means, we usually use, let me find the ways to show addition. Compensation is usually when you do it, for example, if I was doing this problem with compensation, 34 plus 27, let's say I didn't want to do that. I can use modified add-ins where I would say, okay, I'm going to add 6 to this. Okay, and so I would get 40, which would mean I'd have to subtract 6 from this and get 21, and then I'd get 61. So that's compensation because it's like a trade-off. If whatever you add to one of the add-ins, you have to subtract to the other add-end. Does that make sense?
That makes sense because with the one you just showed us, we're not subtracting anything after. So
exactly,
okay.
Exactly. So compensating is kind of give and take kind of thing. Yes. So, but good job trying to use the vocabulary. That's awesome. That's awesome. Okay. So, there is so much with addition. What you're going to do is you're just going to practice it. Oh, look, here's my explanation of the commutative property at the end of your slides. So that's great. And I fixed this part, by the way, so it was correct. So your slides are correct. We talked a little bit about subtraction yesterday. Let's look at some strategies. And some of you talked about this at the beginning, that we would count on our fingers. Look at these two word problems. I have 13 stickers and I give away 5 to my brother. How many stickers do I have left? And then their strategy. And then the other one, Kevin has 5 stickers. James, his brother, has 13 stickers. How many more stickers does James have than Kevin? And look at that strategy. But while you're looking at it, I want you to think about what the structure, what type of problem it is, and what the structure is from yesterday. Okay. All right, so let's talk about this. What kind of problem is the first one? I'm getting nervous. I have 13 stickers and I give away 5 to my brother. How many stickers do I have left? What type of problem is it?
Separate.
Separate.
Yeah, it's separate. How do you know?
They're taking.
Yeah, there's an action verb going on there, right? Do you guys want me to read them out loud to you while you take the final, I mean the midterm, so I can emphasize the word that's going to help you? My point is you need to read them out loud to yourself, right? And if you just don't want to guess, you'll be fine, I promise. So what was the strategy there? Are you guys okay? Are you frantically taking notes?
They used the number line and
Yeah, they did use a number line and they used their hand either way, right? They maybe have used both, but they counted down. So they were at 13 and they had to take away 5. So what they did was 12, 11, 10, 9, 8. And so they knew their answer was 8 by using this or using a number line. Yeah? Okay. So that's a very particular strategy. How about the second one? Kevin has 5 stickers. James, his brother, has 13 stickers. How many more stickers does James have than Kevin? What is it?
Compare.
Very nice. It's a comparison problem. Now, what was their strategy that they used?
Well, they used a very similar one with the finger counting. They just counted up instead of down.
Yeah. And what's interesting about that strategy, have any of you ever worked with young elementary school kids? This is the one that is a huge breakthrough. Yeah. If you've ever worked with kids, this is a huge breakthrough because some kids you'll say, okay, the kid will say, I know I have to add, right? I have to figure out how far I get from 5 to 13, right? And so they'll start counting the original 5 and you're like, stop. You already have 5, right? Let's just start at 5. Yeah. Has this ever happened to you? Yeah. It happens a lot with addition. If you take an addition problem where we take 5 plus 4, a kid will start counting, drawing all of them, like Bethel explained at the beginning, and counting every single one. You don't have to do that. You already have 5. I know I have 5. Now I can just go 6, 7, 8, 9, right? Like that's a huge breakthrough when kids do that. So counting up strategy, that's a big deal. If you don't believe me, talk to a preschooler and try to get them to do it. I promised you, right? How many of you have seen this in preschool? Yeah, it's terrifying. Or they start counting the same ones again and again and again. You're like, stop counting those, right? Especially if they don't have them lined up. I was worried about that little boy in the video. Were you? When he was counting his? Yeah. And at first he did 17. Yeah. Yeah. Betty, what's the question? Can we do 5? Did you have a question for me? Yes, no, maybe. I don't know. All morning we were having tech problem Tuesday, so maybe that's what's going on here, or maybe you're just silent, Sam. I don't know. Oh, I'm not going to do this decompose, recompose. I think we're okay with it. This is definitely something I need to highlight today. Remember we talked about the parts of an addition sentence, yes? Addend, sum. Let's look at the parts of the subtraction sentence. Did you know they had names? Yeah, first of all, the answer after a subtraction problem is called the difference. A lot of us knew that, right? A lot of us knew that. Did you know that the first number in a subtraction sentence is called the minuend? M-I-N-U-E-N-D. And the second number is called the subtrahend. Did you know that? Why did they have different names? Because addend, they didn't have different names. Why do these have different names?
Well, it's important to differentiate them because if you put the subtrahend in front of the minuend or vice versa, you might get a negative number, whereas that can't happen in addition.
Yeah, for sure. So order matters in subtraction, but order doesn't matter in addition. So what could I say about the commutative property?
That it doesn't work in subtraction?
Yeah, absolutely. There's a commutative property for addition, but no commutative property for subtraction. How are you going to remember that? Well, if the two things are called the same thing, they must be interchangeable, right? Addend to addend, I can do them in either order. So that must have a commutative property. Minuend, subtrahend do not have the same name, so you must not be able to exchange those. They must not have a commutative property. Okay. Now, just in case you haven't looked at your midterm stuff yet, this is the stuff that's on your midterm, and you need to be able to spell it correctly. Yes? So if you think that second graders don't know these words, they do. Second graders now are taught the words minuend and subtrahend. Yes? Yeah, it's true. It's true. And especially at a really active school with Common Core that's doing number talks, they will use those words, those vocabulary words. Remember how I told you the day I heard a second grader go, I respectfully disagree with your mathematics because? Yeah, this is the same school where the kid was like, okay, so first I broke down the minuend into blah, blah, blah. And I was like, there we go. I didn't know that word minuend until I became a teacher. So there you go. Now elementary school kids know it. Crazy. Look at those. The difference of 9 and 4, 9 decreased by 4, 4 less than 9. So what's interesting is when we say it verbally, we might move things around, but this problem is always 9 minus 4 equals 5. Even if I say 4 less than 9, that means 9 minus 4. And if I say 4 subtracted from 9, that still means 9 minus 4. Some of you remember having intermediate algebra and missing those problems, right? When you had variables and you were like, wait, is that x minus 4? Is that 4 minus x? Yeah, because it made a big difference in your answer. For sure. Okay, look at this. You have 63 coins at the end of level 1 in a computer game called Dragons. You can spend 49 coins to buy a saddle to ride a dragon. If you buy the saddle, how many coins will you have left? So I have 3 examples of these students thinking. I was going to put them on the same Jamboard, but then they become so long, it's impossible to put them there. So let me see if I can even find this link. And we don't all have to go to the Jamboard. We can. But I'll just share my screen. And these Jamboards, you can make a copy of them. You can write on them with your groups, whatever you want. Just don't delete other people's stuff, right? So I'm going to share my screen with this Jamboard. So Aisha said, I solved this by starting at 63 and jumping back 20 to 43. Then I subtracted another 20 to 23. Next, I took away 3, which got me to 20. Finally, I took away another 6 to 14. That's the answer. And it says, model her work on a number line, circle the answer, and then show it with symbols. So we would start, now be very careful because there's a video and I don't think I fixed it in modeling subtraction that is actually backwards. So listen carefully. I would not start here at 63 because that's the left side of the number line. I would start, I would start over here at 63 because that's where it should be. So I'm here at 63. I'm going to jump back 20 to 43. I'm going to subtract another 20 to get to 23. And then I'm going to take away 3 that got me to 20. And then I took away another 6 to get me to 14. And that's the answer. Now, remember, this was the problem they were doing. 63 minus 49. So they decomposed, right? Do you see how they did it on their number line? So they did 63 minus 49, but what they did was they broke down this into really 4 things, 20, 20, 3, and 6. And then they did 63 minus 20 and got 43. And then they did 43 minus 20 and got 23. And then 23 minus 3 and got 20. And then the 20 minus 6 and got 14. And my writing is terrible over here because I write too big. So sorry about that. And you can make a copy of this or whatever you want. So that was one strategy. If you look at a different strategy, they did it differently. And then a third strategy. Oh, maybe that's just the same one. I don't know why that is there. Because it should have been, and then I have the other strategies there. But, and then later, we're going to talk about this strategy, which you're going to get in your video. This is what who was it? McKenna was talking about before with compensation. Look at this problem right here. They're still doing the same math problem, right? What did they do on this problem? I'll give you a couple minutes to think about it. Sunita put it in the chat. They're subtracting and then adding. So what are they actually subtracting? Yeah, Madison said it. I could read lips there. They did 63 minus 50, right? And they got, because they thought that was easy. And then they added 13 plus 1 and got 14. So here's their answer. 14. But do you see how they recorded it on their number line? Now, what I would prefer if I was teaching this to my students, I like arrows a lot. So I would draw an arrow this way. So I knew I started here and went here. Does that make sense? And then I would draw another arrow that I went here. And sometimes I even do it like this. You've probably seen teachers do this. Come up from the bottom, so it's a little less confusing. So are you seeing how you might record things on a number line? Yeah. Excellent. Okay. The other strategies are on a different page, but what I really want to get to, and I'll probably make a video for you on the rest of this, is when you get to something called constant difference. So here's an example of constant difference. In the ultra marathon, there are 8 stations at the 32 mile and the 28 mile. How far apart are these two aid stations? Well, we would know they're 4 miles apart, like you and I would, but an elementary school student might have trouble with it. And sometimes elementary school kids have trouble with subtraction problems where they have to regroup. Yeah. So they can change the problem to something where they don't have to regroup. For example, instead of doing 32 minus 28, they could do a problem where they would say, add 2 to this and add 2 to this. So they would say 34 minus 30. Do you see how 34 minus 30 is an easier problem than 32 minus 28? Because when we do 32 minus 28, this is where it gets real sketch for kids. They go, mark this out and change it to a 2. Put a little 1 here. Now you're doing 12 minus 8, which is 4, and 2 minus 2, which is 0. Do you see how this is a lot more complicated than just this? So this is called constant difference. It's not compensation in the sense that we did with addition, because we didn't add something to one of the addends and subtract it from the other addend. What we did was we just moved it over on the number line. Yeah. Have you ever thought about that? When we're trying to find the distance between them, it's not going to change if I add the same thing to both of those numbers. Yeah. You probably do this and you don't even realize you do it all the time. How far apart are you from your sibling? Do you know that? Does anyone know that in their head? Like I know, right? My oldest sibling is 7 years older than me. She's always 7 years older than me. It doesn't matter, right? So if I know how old I am, I know how old she is, and I can adjust my math problem because I know that constant difference. Yeah, so Karina, you probably use this strategy a lot and you don't even realize it if you know your sister's 5 years or you're 5 years older than your sister. Okay, nice. Excellent. So if you know how old you are, you know how old they are. You don't have to do that subtraction every single time, right? Okay, so this can become nice problems. Look at this. 53 minus 18, if a teacher gave you that problem, that's a pain in the butt. Is there anyone who does this naturally? Change it to a problem like 55 minus 20. Yeah, McKenna says she does. Hannah does. My husband does all the time. There's others of us that were taught so traditionally, we're still doing this, writing in the air, right? Yeah, Emma's on my page, right? I see your face. Yeah. So if you've never done this, try it. It's amazing. It's life-changing, I promise you. And if you can teach these skills to your students, it's going to really help them be more confident in their mathematics before they get too deep into more complicated math. So this is called constant difference. Here's another constant difference, right? Now, some of you are going to struggle and you're going to try to make it easier and you're actually going to make it just as hard. So the idea is to get rid of regrouping, right? That's your object or your goal. Okay. So some people, I've had people who are first learning this and they're like, okay, 81 minus 33. By the way, I write everything vertically and they write everything horizontally. It's just a difference. It doesn't matter. Okay. So I have had people go, oh, I'm going to change this to 80. So I subtracted 1 here. So I'm going to change this to 32. Do you see how that doesn't help at all? It actually made it worse, right? So don't do that What you want to do is make it so, let's use our correct vocabulary. The ones digit in our subtrahend is smaller than our ones digit in our minuend, so no regrouping has to occur. Does that make sense to you? That's the idea. That's why they chose to go to 78. They could have chosen a different number, right? But they made it real nice because they made this a 0. So what they really did was look at this 3 and said, what's the closest 10, right? That I can make it smaller than, and do that. Okay. Now, I'm sure you guys feel like we went crazy, crazy fast through everything. And we did, no doubt. No doubt. How many of you honestly, tell me honestly, how many of you are previewing your slides before you come to class? 1, 2. Oh, that's 2 more than I thought. Good job, Tristan and Alyssa. Good job. Okay. Tell me honestly, do you think it helps, Alyssa and Tristan? Tristan's on the fence. Maybe, maybe not. Maybe not when I'm so crazy, right? Trying to fly through them. But Alyssa's like, yeah, I think so. I think that if you just try to do them, you don't have to scour them, right? But just preview them. So when I'm talking to you, like today was better because a lot of you were like, oh, compensation or constant difference or, you know, something like that. But you have access to these, right? It's going to help us have a more interactive community. This is what I do not want. I do not want 80 minutes of me talking and you sitting like this. Or even sitting like this. I need you here, like interacting with me. Okay? Because that's the only way you're going to learn it. You don't learn these things unless you're actually doing them. Okay? So let's try to preview the slides for tomorrow before you come to class. Okay? Preview those slides before you come to class because we didn't even get to do some of the things that I wanted to do. And tell me, how many of you have trouble writing on the Jamboards? Raise your hand. Be honest if you have trouble writing on the Jamboards. Yeah, so about half the people have trouble writing on the Jamboards. That's why I stopped it because I was like, okay, if nobody's writing on it, it's completely pointless, right? So you have to find a strategy that's going to work for you. If it's this, do it, right? If it's electronic, like Sunita has shown us, do it that way, okay? Because we're only in week 3 and today was probably overwhelming for you and not super fun for me either, let me tell you, okay? Because it probably seemed all over the place, right? But if you go through my slides, it's a beautiful plan, right? It's just getting it there, okay? I have a lot too. And maybe you're like, maybe you just have too much stuff there. That's probably facts. That's probably true, right? So I'll try on my end to weed it down as well. But you guys already know how to add and subtract, right? So we need to really practice these new techniques. And when we get to fractions, not all of us understand fractions the way we're supposed to. Yeah, that's just facts. So I really need you engaging with me so we can do it, okay? And I hope you're not taking this negatively because I don't mean it negative at all. I want you to get the most out of this class possible. And I want it to be an enjoyable experience and a give and take. If you have an idea on how we can share information better, let me know. I'm there. This technology is challenging, right? So let me know what helps if you have something specific. Okay. So hopefully we can, oh, by the way, this is so fun. Read this brain break if you didn't. I'll try to make a video for you, but I do have to get all those graded. If you're wondering about base 10 blocks, if you need help with the home assignment, here's a lot of examples in here on what it should look like and what your steps are, okay? A lot of these, again, just have examples there so you could go through it because I do teach this online. So my students go through the slides on their own. Okay. And then our exit ticket is, I don't think it's going to be too bad for you. You let me know if it is. And then tomorrow is a new day. I will do my best, make a video for you about the rest of these slides that maybe you feel like, what is happening right here? If you want to work on the Jamboard, I'll put some notes on the Jamboard. And then tomorrow, maybe if we need to clear anything up, I'm happy to email me. I'll write a new warm up for tomorrow with just some fun things like practicing, and then we'll jump into multiplication. Okay. Because we're supposed to spend the next 2 days on multiplication, as far as I remember my slides. Okay. Questions, do your exit ticket. I know if you have to go, but good job. I know it's a lot to digest.
I have a quick question.
Me too.
So I was wondering, I know we have the group assignment due on the 8th. Are we going to have time in class to do that, or is that something that
No.
we need to meet up with? Okay.
Yeah,
Okay.
it's
And
not
then,
in class at all.
okay. Oh wait, you said it's not in class?
Never in class. Nope.
Okay.
It's all on your own. So, and it can be asynchronous, right? You guys don't have to meet all at the same time. You can just make a plan for how you're
Okay.
going to do it. Yeah.
Okay. And then one more thing. I liked the example you did for the constant difference with the subtraction, because the one that I watched on the video, it had, so for example, it was like 126 minus 87, and they both added 3 to the 126 and then the 87. But on the example you did, they were different numbers, but you subtracted 3 on both of them. So I was just wondering, can you add and subtract using this and that works fine?
That's a great question. And McKenna, absolutely, because you're either shifting up or you're shifting down. You can do either one.
Okay, and would it be the same for the addition one, the compensation as well?
Yep. So with addition, you just have to remember whatever you do to one, you have to do the inverse operation to the other. So if you add to one, the one add end, you have to subtract from the other add end. And my advice to you is try it a few times and then try it traditionally or check it with your calculator and make sure you're still getting the right answer, because it should work, right? If it's mathematically sound, you'll be fine. Yeah. And come with me and we'll practice too. And you can always send me an email that says, I just need one more example of this. Because if you need it, probably 10 other people need it and they're just not asking. And maybe I can make a quick little video or I can send you an explanation. But yeah, I'm totally willing to do that. Thanks for asking, McKenna.
Okay, thank you so much. I appreciate your help.
Yes. Anyone else have any questions for me? Hannah, you have one? Oh, you were just saying bye. Bye. Tyler, Sunita, Kelsey, you doing okay?
Yep, I just like to hang out in case someone has a question that I don't think of, and I go, "Oh crap, I didn't think about that." And then
I know. And that's why I always like when people ask me questions, because I'm like, oh, I didn't say that. Are you kidding me? I'm so sorry.
for some reason, I seem to be clicking with this a lot easier than I thought I was going to be, though. So I'm glad.
Yeah. And for most people, it's just trying it out, and having faith in it. Like, oh, I can think about things differently than I did before. And then just naming things, knowing the vocabulary is probably one of the hard things.
Yeah, same
Good.
with Tyler. I was just waiting to see if anybody had anything. Other than that, I think I'm fine. I realized
good.
today that when I do add, I do doubling a lot. So
Yeah, what's funny is we haven't thought about it. Nobody asked us to think about how we're doing math.
yeah,
Yeah.
I always add the doubles and then I just add whatever's left every time. That's so funny. Alrighty.
That is funny.
Um,
Okay, good.
All right. Thank you. I'll see you tomorrow.
All right. See you tomorrow.
Bye.
Bye.
With that, I'm out as well. Thank you so much for everything. Sorry I had to dip for a few minutes. I was not expecting that to happen like right during class.
No, you're good. No worries.
But we will see you tomorrow.
Okay, cool. See you tomorrow.
Bye.
Kelsey, you doing okay?
Yeah, I